So let's talk about the derivation of total resistance of resistors in series. That means we need to know what is the total resistance between these two points. These are total. What we're going to get at the end is that the R total is the R1 plus R2 plus R3 plus until the last resistance Rn for the series connection. So to demonstrate this relation, we can just study the case of a circuit containing just two resistors. So let's have a certain circuit composed of two resistors with a power supply V. So this is the resistor R1 and this is the resistor R2. Okay, so let's assume this is the potential difference of the power supply. Of course, the other power potential difference for R1 and R2 are those. Let's name this one V1 and this one is V2. So as the Ohm's law says, for R1 and R2 to do two resistors, we have V1 is just like the R1 times I, and the V2, the potential difference across each resistor here is R2 times I. It's gonna be the same currents that's flowing through all the circuit here. So for the Kirchhoff's law for potential difference, we have V minus V1 minus V2 would be equal to 0. Or even we have V equals R1, or this is V1 plus V2. Now, if we substitute the V1 with V2 by their expression, that's gonna be V would be equal to R1 times I plus R2 times I. Just we can factorize by I. It would be equal to I times R1 plus R2. And of course, we do have the total potential difference. It's something just like the current times the sum of these two. V would be equal I times R total. That means for our case here, R total will be equal just the sum of the two, R1 plus R2. And this is the case for any number of resistors. That means once we want to calculate the total resistance for a series circuit, we can just add them up. Now, when the circuit or the resistors are connected in parallel, what would be the total resistance here? So first of all, we need to know what is the Kirchhoff's law for currents here. We say that in a certain node, the sum of the currents getting in this node is equal the sum of the currents coming out of the same node. That means let's assume this is the I, the total currents coming to this node. Let's name this one, it's I1, and this one is I2. That means for this node, we can write the law here. I would be equal to I1 plus I2. Let's assume these two resistors are connected to a power supply here, with the potential difference is V. This is a plus, this is a minus, and this is of course the direction of the main current. Now, because the power supply and the two resistors are connected in parallel, that means the same potential difference is applied across each component of this circuit. The same V is applied across the R1 and the R2. What does it mean? For this V, we have V would be equal to I times the R equivalent, or even the I total. What about the resistor R1? So the V1 would be equal to R1 times I1. For the R2, V2 would be equal to R2 times I2. What did we say before? The V is the V1 is the V2. So for these two, we can get the expressions of I1 and I2. This is gonna be I1 is the V1 divided by R1, and I2 would be equal to V2 by R2. Let's go back to the Kirchhoff's law for the currents. We have this is given for, of course, the total currents would be equal to V by R total. Let's substitute each current by its expression. We have the I, which is V divided by R total. That would be equal to I1, which is the V1 by R1, plus the I2, which is V2 by R2. This is gonna be the V divided by R total would be equal to the V1 is exactly the V2. We can just factorize by the V. V times 1 by R1 plus 1 by R2. So what does it mean? Finally, in parallel circuits, 1 over the R total. I said 1 over R total would be equal to 1 over R1 plus 1 over R2. We can rearrange this equation mathematically. Will be R total would be equal to R1 times R2 by R1 plus R2. So this is for the parallel. Let's have a look to this case here. Once we have multiple resistors connected to just like in parallel, so we can apply the same relation. The total resistance here, the inverse of it, 1 over R total would be equal to 1 over the first one is R1 plus 1 over R2 plus 1 over R3 plus until the last one, 1 over Rn, and we can derive this expression also just like as we did for the example of two resistors.